Okay, we are going to try and tie all of this together with a lull diagram. The lull diagram is a qualitative diagram that shows some energy transfer. So we're looking at the energy flow of a system at several different points. Could be 2, could be 6 points. We will determine that as well as our system. This is the general look of a lull diagram. You've got your 2 points that you're looking at, snapshot 1 and snapshot 2. You've got your system in the middle, and on the bottom part of the graph, you've got the different types of energy that you could have. So kinetic, gravitational potential energy, spring potential energy, and this delta E internal, INT means the internal energy. So energy that's gained from heating up or having the molecules smash into each other, or vibrations that cause some sound. So we will use this diagram to qualitatively look at different events that are occurring. So I'll start off with an example here. I've got a sock that I pull up to a certain height A, and then I drop it. The way we use our diagram is we use the L's for each snapshot, and I'm going to take 4 snapshots here. Before I drop it A, and then when it finally hits the ground and is at rest at D, and then 2 points in the middle. So this will look like this. It'll be a LOL diagram. My system, I will say, is the sock, earth, and floor. I'm choosing the floor too so that there are no external forces present. And you'll see why and how that is convenient in a minute. So the first energy diagram looks something like this. All of my energy at A is in gravitational potential energy. I just decided on 5 blocks. This is kind of arbitrary. It just shows that all the energy is in gravitational potential energy. And the O is the system. Look at and see here the sock, earth, and floor are the things. It's the same system, the entire problem. So you're going to want to define your system and immediately write your system objects in the circles. And then you can start moving along to putting the blocks in for particular energies. So we got A out of the way. The next thing is B. So you see here in B, the sock has fallen down a little bit, but it's still up in the air. So I still have some potential energy. Defining, I guess I should have said this earlier, I defined the ground to be 0, and up here is some positive energy. So I've got some gravitational potential energy, and since it's fallen a little bit, it's picked up some speed, so it also has kinetic energy. I still have 5 blocks, but now they're distributed a little bit differently. The next event is C. It's the moment before the sock hits the ground. And in C, I've drawn here, there's no more potential energy because it's basically at the ground. All of it has converted into kinetic, so I have 5 blocks of kinetic. Take note that if there's no energy for like a particular energy store, like spring energy, I crossed it out with an X. And it's completely irrelevant here because there is no spring acting, so I crossed it with an X. At this point, there's no gravitational energy, so I X'd it, and there's no change in the internal energy, so that's X2. Finally, the sock hits the ground and comes to rest. What happens there? Well, I no longer have kinetic energy. I X that. I no longer have spring energy, or gravitational potential energy, as I should say. But all of it is now in change of internal energy, meaning the sock may have heated up a little bit, the atoms may have rearranged themselves, the sock itself changed shape, so the internal energy has changed a bit. And all 5 blocks are over there. So at each snapshot in time, you still have 5 blocks because there's no work being done. What if there was work being done? Remember back to the skateboard problem that we looked at in class. You've got a skateboarder in a rope system. excuse me, I'm going to define the system to be, in this case, just the skateboard, so that there is some work being done. There is a net external force, and I'm going to show you how the wall diagram looks for this. My system is the skateboard and the earth. It's important to choose the earth because without the earth, you don't have any gravitational potential energy. Not that it matters for this case because you're on the ground, but for this problem it did matter because you were off the ground. So it's important to choose the earth for our system. Back to this one. I've got the skateboard and the earth. I did not consider the rope to be part of the system, so this needs to be drawn on the outside with an arrow going in. At the beginning, my skateboard is still, no kinetic, no spring, no gravitational potential energy, no change in internal energy. After the rope starts pulling, there's some work done. I now have kinetic energy in the skateboard and some change in internal energy because the wheels have heated up. There's some sound because of vibrations of the objects. And I can see that in my qualitative lull diagram. I hope this was helpful, guys. I will see you in class soon.